Welcome to the Walton Pi. Today I'm going to go through a bunch of problems that will likely show up on the calculus test for the students that I am working with this semester. So to get started, let's go through and start with identifying derivatives based off of a graph. So all of these functions, I'm going to label this one A, this one B, this one C, and this one D. So we are trying to figure out which of these is our function f, which one is our function f prime, which one is our function f double, is a distraction. Okay, so one of these is not going to get used. So we're going to try and figure out how could we identify which function is which. So the best way to start is just pick a function and see if we can find its derivative. So let's just start with a and see if we can find the derivative of a. Okay, so let's start off by looking at our a curve. So let's look for some spots that are easy to identify. For example, these two spots, the derivative of a, so the slope at those points is flat in both cases. So what that would mean is the derivative of a, so the derivative of a is going to have to be 0 here and here. So we would go up from there and we'd say, oh, we have two possibilities. So that means that the derivative of a is either going to be b or c. Now the question is, how can we figure out which one it is? Well, what we would do is we'd look at these different functions themselves and see if we can eliminate one of them. So for example, let's look at b, for example. So at b, there's a few different spots where it's equal to 0. It's equal to 0 there, 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 and there. So there's 5 different spots where b is equal to 0. But there's only 2 spots where a is flat, which means that b is not going to be the derivative of a. Okay, so we can eliminate b as being a derivative of a, which means that our most likely contender is that the derivative of a is going to be c. And then let's go and check that that actually makes sense based off of the rest of the a is increasing, so that means that the graph of its derivative should be positive, which it is. Then here, a is decreasing, so the graph of c should be negative, which it is. And then here we have the graph of a is increasing, so that means that the derivative graph, so c, should be positive, which it is. So that gives us all a bunch of different things that make it quite likely that the derivative of a is in fact c. So let's see if we can find the derivative of c, or maybe find something where the derivative of a is going to be that. So let's first look at, is a the derivative of anything here? So a has a few spots where it's equal to 0. So it's equal to 0 at those 3 spots. So in order for a to be a derivative, it would mean that at each of those spots, or if a was the derivative of a function, that function would be flat at those spots. And at this spot here at -10, the red graph is flat, so that's a possibility. But then here at like -3, the red graph is not flat. So that means that the red graph, its derivative is not a, which means that we can eliminate all of them as being a possibility. So that means that a is not the derivative of any graph that is shown currently. But let's then look at c to see if its derivative is anywhere. Well, let's do the same sort of thing we did for a and see if we can find any of those. So right here, c is flat there, it is flat here, and it is flat here. So that means we need something that is 0 at all those spots. So for this first one, both the red and the black graph are 0 there. And then the next one was right here, but this time only the red graph is equal to 0 at that point. So that means that the derivative of c is d, and so that means that a double prime is going to be d. So we have successfully figured out what each of these different things are. In this case, the graph of b was our distraction. I hope that made sense. If it didn't, just graph a bunch of functions on Desmos. You can say something like, so if you enter something like f of x equals x cubed plus 4x minus 7. Then you can also graph f prime of x in the next line, and it will automatically graph its derivative. So you could type whatever sorts of functions you want, and then generate f prime, f double prime of x, and then you hide the thing and try and identify. That would be a good way that you could be able to study for this. But let's move on to another topic. So let's say that we know f, g, and h are differentiable functions. So that means all of these we can take derivatives of. So we want to know what is f squared g minus f over h squared prime. What is the derivative of that? Well, let's go through this piece by piece. So we're going to be using the quotient rule, the product rule, and the chain rule in this. So for this first one, f squared times g, that's a product rule. So what we'll have is we'll have first times the derivative of the second. So that's going to be f squared times g prime plus the second times the derivative of the first. So we need to know what's the derivative of f of x squared. Well, that's the chain rule. So we have something squared. That means it's going to be 2 times that something multiplied by the derivative of that something. So that's the derivative of that first piece. So that goes to all of this piece. But then the next one is we have the quotient rule on the next one. So this one is going to be low d high. So we get low d high minus high times the derivative of the bottom. So the derivative of that's going to be similar to the last 2 times h all over, so that's all over h to the fourth. So there we go. That is how we would find the derivative of this. And we could simplify a little bit. We could cancel an h out from everything, but that would be how we would take the derivative. Okay, let's now do a specific example. So let's say that we are told that f of x is equal to tangent of cosine of e to the x plus 2x minus 3. And we are trying to find f prime of x. So go ahead, pause the video, and try and do this on your own first. Okay, a very common mistake with this one, so be very careful with this, is a lot of students would write tangent, well that's sine over cosine. So it's sine over cosine of stuff, and then they say, oh, I can just cancel those cosines. That is not true. Okay? We cannot cancel them that way, because this is tangent of cosine, not tangent times cosine. Because yes, tangent theta times cosine theta, this is equal to sine of theta, but tangent of cosine of theta, this is sine of cosine theta divided by cosine of cosine theta, which is not equal to just sine of theta. Okay, so this stuff that we were looking at up here, that is false. So be very careful with those sorts of things. That is not something that we can do. So, with that very common error out of the way, let's go through and take the derivative of this. So this is just going to be a chain rule, so we need to know what are the derivatives of each of these pieces. So let's look at them. So the derivative with respect to x of tangent of x, well, we can use the quotient rule on this. We can rewrite this as the derivative with respect to x of sine x over cosine x, and then we would eventually be able to show that this is equal to secant squared of x. The next function inside is the derivative of cosine, which is one of the ones that you need to have to memorize what the derivative of cosine is. That's a So with all of those pieces together, how do we combine these to get the chain rule problem? Well, the derivative of tangent is going to give us secant squared of everything else stays exactly the same inside. So the inside pieces do not change. So we have that. Then we're looking at the derivative of cosine, so that's times Derivative of cosine, that's a negative sine of, and then the inside piece stays the same. So it's still sine of e to the x plus 2x minus 3. And then we multiply all of that by the derivative of that insidemost piece, which is the e to the x plus 2. And that is the derivative. Sine all the way out squared of the x plus 2 times sine of e to the x plus 2x times e to the x plus 2. You could move the negative sign out, but as it is written, that is a good way of being able to express this answer. Okay, now let's do a chain rule problem where we are not given the specific functions. So let's say that we are given the following. We know that big F of x is equal to little f of little g of x, and then we are told the following pieces of information. We know that f of 2 is 4, we know of 7 is 5, we know g of 2 is 7, g of 4 is 2, we know f prime of 2 is negative 3, f prime of 7 is 2, g of 4 is 2, and g prime of 4 is negative 6. We are asked, what is f prime of 2? What is that? Well, how would we find that? Well, let's go through piece by piece, but before I do it, pause the video and try and do it on your own. Okay, so first, let's write down what f prime of x is. This is going to be the chain rule, f prime of g of x times g prime of x. So that means that if we're looking at f prime at 2, that'll be f prime of g of 2 times g prime of 2. Is negative 1. Okay, so we have this. Now we're just going to be plugging in. So it's going to be f prime of 2, that's 7, of 7 times g prime of 2, that's the negative 1, f prime of 7, that's 2, 2 times negative 1, that all gives us negative 2. So we know that f prime of 2 is negative 2, based off of this table. And that's how we would go through and do it. Now let's try and figure out what is big F prime at 4. Well, that will be f prime of g of 4 times g prime of 4. So this will be f prime of g of 4 is 2 times g prime of 4 is negative 6. F prime of 2 is negative 3. Negative 3 times negative 6, that is positive 18. And that's how you would go through and do this problem. Okay, let's look at a just straight up quotient rule problem. We have f of x is equal to e to the x minus 4x cubed divided by 2x minus 1. Okay, we are looking at what is f prime of 0. Cubed d low, that's just 2, all over the bottom squared. Plugging in we're here. So that means we get 0, so that's a 1 minus a 1 times 2, all over 2 times 0 minus 1, so that's okay. Let's talk about trig for a moment. So what are all the trig things that we are going to need to know for this test? So there are, I'll go through the most important ones, and then I'll talk a little bit more about some of the more useful ones to know. But let's start with the most important ones. So the most important things are you need to know all of the trig functions. So we have sine of theta, we have cosine of theta, tangent of theta. It's important to know that tangent of theta is sine of theta divided by cosine of theta. We have cosecant of theta, that is 1 divided by sine of theta, which is not the same as inverse sine of theta. That is a very important thing. Cosecant is not inverse sine of theta. That is a very, very common mistake on tests. So be sure to know the difference between inverse sine and cosecant. Secant of theta over sine of theta. Cotangent of theta. And this is also then it might also be useful to know what sine, cosine, and tangent are in terms of the sides of a triangle. So if there's theta and we label these opposite, adjacent, let's make that clear, it's an O, and then hypotenuse, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So those are some key things to remember. Another one is sine squared theta plus cosine squared theta is 1. And then the other most important thing to know is the derivative of sine is cosine, and the derivative of cosine is negative sine. Be sure to remember that negative sign. Okay, so find some way to keep track of which one's positive, which one's negative, but be sure you remember all of those. And then to find the derivatives of any of these trig functions, just use the quotient rule. And that'll give us a way of being able to find those. So these are the key, most important trig functions to remember. Okay. The other trig functions theta, two theta, fairly frequent, super often. The ones that I listed on the previous part, those are definitely the most important ones to remember. So now that we've covered all of those, let's look at a derivative. So what is the derivative with respect to theta of cosine theta cotangent theta? Okay, if you have a trig function and you're trying to find its derivative, the best way usually is to try and simplify as much as you can before, or just convert everything to sines and cosines. So let's convert this into sines and cosines first. So this is the derivative with respect to theta of, well, cosine theta is already in terms of cosine and sine, but then cotangent, that's going to be cosine theta divided by sine theta. So we are really looking at the derivative with respect to theta of cosine squared theta divided by sine theta. So now we're going to use the quotient rule. So that's going to be low d high sine theta times, what's the derivative of cosine squared Well, cosine squared is cosine theta times cosine theta, or cosine of theta all squared, so we can use the chain rule. So that's going to be 2 times cosine theta to the 1 multiplied by the derivative of cosine, a negative sine theta. So that's low d high minus high d low all over the bottom squared. So all over sine squared theta. And now let's try and simplify. So we have a negative sign that we can pull out from everything. So let's just pull that out. And then we are left with cosine theta times sine squared theta plus cosine squared theta all over sine squared theta. Would you look at that? We have sine squared theta plus cosine squared theta. That goes to a 1. So this is negative cosine theta over sine theta, which, squared theta, which we can simplify as negative cosine theta over sine times 1 over sine theta, which is negative cotangent theta cosecant theta. And there we go. That is going to be the derivative of this function. We just used the quotient rule. We went low d high minus high low all over the bottom squared, and we just simplified and wrote it down in as nice a way as we could. And that is how we would be able to go through and do this problem. Okay, but let's talk about a few other things, because we're also going to be seeing some other types of problems, not just use the quotient rule, use the product rule, use the chain rule. We're also going to be having some stuff where we have to do stuff using the definition of the derivative. So let's do one of those. So find the derivative with respect to x of 3 divided by 7 minus x using the definition. So go ahead and try and do that on your own before you watch how I do it. Okay, so what I would do is I'd first say, well, what's my function? So it's going to be a 3 divided by 7 minus x. And then the definition is going to say it's the limit as h goes to 0 of f of x plus h minus f of x all over h. And now we're just going to plug in. So this is the limit as h goes to 0 of 3 divided by 7 minus x minus h minus 3 over 7 minus x all over h. And now we need to try and simplify. The way I'm going to do this is I need to somehow get rid of this piece. So what I'm going to do is I want to multiply the entire time by 7 minus x minus h, but then I also want to get rid of this piece. So I'm also going to multiply the top by 7 minus x. Now I can't only multiply the top by stuff, so I'm going to have to multiply this bottom by those same things. Because this is now just multiplying by 1. So I multiplied the top by what I wanted, and then I multiplied the bottom by what I needed to in order to keep everything still equal. And now when I multiply all of this through, I will get the limit as h goes to 0 of, we have 3 over 7 minus x minus h times all of that. The 7 minus x minus h is cancelled, so we're left with just a 3 times 7 minus x. And we have minus 3 times, this time is the 7 minus x's that cancel, and we are left with a 7 minus x minus h on the top. And the bottom we have h, 7 minus x, and a 7 minus x minus h. All of that's on the bottom. And now we just need to simplify. So let's expand out the top. Limit as h goes to 0. We have 21 minus 3x minus 21 plus 3x plus 3h all over h times 7 minus x times 7 minus x minus h. Well, would you look at that? We have a 21 and a minus 20, a minus 3x and a plus 3x, and we're left with just 3h over h times stuff. So all of this stuff, all of that cancels out nicely, and then we can cancel this h and that h, and we can now evaluate when h is 0. And we get 3 divided by 7 minus x times 7 minus x minus 0, so this is 2 of those. The answer is 3 divided by 7 minus x squared. And we can check that using the quotient rule, and everything works out exactly as we'd hope, and that is going to be our answer. Now it's important, don't use the quotient rule on this when it asks you to use the definition. You can use it on your scratch paper to check, but that is not using the definition, so you have to go through and use this limit definition to find it. Okay, let's look at one more problem with derivatives, and then I'm going to talk a little bit about limits. Okay, so this might be a free response question. It'll be something like find all tangent lines to y equals, and then they'd give us some function, maybe 4x minus 3 divided by 3x minus 2, parallel to the line of, let's see, x plus 4y equals 0. Okay, how would we do this problem? Go ahead, try this problem on your own first, and then come back, unpause the video, and we will try this together. Alright, so the first thing we need to do is figure out what's the slope of the line that we're trying to get it parallel to. So I would take this line and I would rewrite it as 4y equals negative x, y equals negative 1/4. So that means we are trying to find that. So let's go and see, first off, is there anything that's going to make that work? So when we go and take the derivative, we're going to use the quotient rule, so low d high, 3x minus 2 times 4 minus high d low, 4x minus 3 times 3, all over the bottom squared, 3x minus 2 squared. That's equal to, let's see, 12x minus 8 minus 12x plus 9. That's a 1 over 3x minus 2 squared. And that's always positive, so where did I mess up? Oh, duh. Sorry, my mistake. X minus 4y equals 0. Okay, so that means that all of our signs are positive. So we are looking for when y is positive 1/4. Okay. Y is 1/4 x. Wow, I was really bad there. Okay, so that's what we're trying to do. So we're trying to find where is the slope 1/4. So we are going to solve that. So slope needs to be equal to 1/4, and that's equal to 1 over 3x minus 2 squared, which means that 4 is equal to 3x minus 2 squared, which two cases, either 3x minus 2 equals negative 2 or 3x minus 2 equals positive 2. In the first case, this just means that x is 0, and the second case, that means that 3x is 4 or x is 4/3. So those are both places where the slope is going to be 1/4. So that means that those are our two x coordinates. Now we just need to figure out where the tangent lines are. So let's plug those in to figure out what those y coordinates are. So f of 0, that's going to be 4 times 0 minus 3 over 3 times 0 minus 2. That's a positive 3/2. So that means one point is 0 3/2. And then the other point is f of 4/3. And that's going to give us 4 times 4/3 minus 3 divided by 3 times 4/3 minus 2. So that gives us 16/3 minus 3. 3 is 9/3. 16/3 minus 9/3, that's 7/3. Divided by 4 minus 2 divided by 2. So that gives us 7/6. So we also have the point 4/3, 7/6. So now we have 2 points, and we have the slope that has to pass through both of those. So that means we can use point slope form. So y minus y1 equals our slope times x minus x1. And if we go through and do that for both these lines, we get y minus 3/2 equals 1/4 x minus 0, which is the same thing as the line y equals 1/4 x plus 3/2. And the other one is y minus 7/6 equals 1/4 times x minus 4/3, which is y equals 1/4 x. 1/4 times minus 4/3 is a minus 1/3, and then a plus 7/6. Let's see, 7/6 minus 1/3, that's minus 2/6. So this is a y equals 1/4 x plus 5/6. And so these are the two tangent lines that are parallel to the line x minus 4y equals 0, and they both will pass through a point on that line. So that's how we would go through and answer this particular question. Okay, all that I'm going to go through now is we're going to do two limits, and we're going to sketch a graph. So let's do those limits and then sketch that graph. So first limit, I'll actually just write both of them. Limit as x goes to infinity of 3 minus e to the 2x divided by 5e to the 3x minus 7. And the other one is the limit as t goes to negative 2 of t squared minus 4 divided by 2t squared plus t minus 6. Okay, evaluate both of these limits. Okay, so for this first one, we're going to want to get rid of some of those e to the 2x's, or e to the 3x's. We need to get rid of some of those e to the stuffs. Because as x goes to infinity, the top's going to negative infinity, the bottom's going to infinity. That's an indeterminate form. We don't know what's happening. So we're going to multiply the top and bottom by, I'm just going to pick the power of e that's on the top. So e to the minus 2x, e to the minus 2x on the top and bottom. And this gives us the limit as x goes to infinity of 3e to the minus 2x minus 1 all over 5e to the x minus 7e to the minus 2x. And now we can plug in and we can see what happens as this goes to infinity. The top, this term goes to 0. This bottom term, that's going to go to 0. So this is just minus 1 over 5e to the x, which goes to a minus 1 over infinity, which is going towards 0. So this first limit is actually equal to 0. Now how about this bottom one? Well, anytime we are going to a point, let's first see if we can plug it in. Well, the top goes to 4 minus 4, which is 0, which means this limit goes to 0 unless the bottom also goes to 0. So just because the top goes to 0 does not mean that the limit goes to 0. We have to make sure the bottom is not going to 0 to be able to immediately jump to this limit goes to 0. But if we plug in negative 2, we get 2 times negative 2 squared, so that's a 2 times 4, so that's 8, minus 2 minus 6. This is a 0 over 0. So this does not necessarily go to 0. So that means somehow this will factor and we can cancel it out. So let's try and factor this out. So t goes to negative 2. The nice thing is, because the bottom went to 0 at negative 2, we know t minus negative 2 has to be a factor on the bottom. So we have to figure out what's the top, what's the rest of it. Well, we need a 2t squared, so that means we need a 2t, and we need a minus 6, so that's going to be a minus 3 there. And that's how this bottom piece factors. And the top will factor is t plus 2 times t minus 2. We can now cancel those, plug in negative 2, and get negative 4 divided by negative 4 minus 3. So this is a positive 4/7. There you go. Okay, now for our last one. I'm going to give a few different requirements for a function, and then you are going to have to try and graph this. So, sketch f of x if f of 0 is 4, the limit as x goes to positive infinity of f of x is 2. The limit as x goes to negative infinity of f of x is negative 4. We have the limit as x goes to 0 from the left of f of x. That goes to infinity. The limit as x goes to 0 from the right of f of x, that goes to negative infinity. And then the last one is the derivative of x is bigger than 0 on the interval from negative infinity to 0 and from 0 to positive infinity. Okay, pause the video and try and graph this function. Okay, let's go through piece by piece and try and get what's going to have to happen here. So f of 0 equals 4. Let's come and plot that. So 0, 1, 2, 3, 4. F of 0 equals 4. It has to pass through that point. Okay, the limit as x goes to infinity is 2. So as we go towards infinity, it needs to be equal to 2. So it's going to be flat like that there. And then as we go off towards negative infinity, it's going off to negative 4. 2, 3, 4. It's going out that way. Okay, so we have currently done that, that, and that. Okay, the limit as x goes to 0 from the left of f of x is positive infinity. So that means as we get close to 0, it's going up and up and up. So it's going to be going like that there. But then as we go towards 0 from the right, it's going off towards negative infinity. Okay, and then the last piece says that the derivative is bigger than 0 everywhere except at 0. So what's the derivative being bigger than 0 mean? That means that the slope is positive. So that means it needs to be going upwards everywhere except maybe at 0. So right here it needs to be going up, it needs to be going up, it needs to be going up. That's actually probably, let's try and do it this way. So that's it going up. Here's it going off towards the negative 2. Let's actually fix that a little bit. There we go. That is a graph of f of x that would satisfy this. Notice that everywhere the slope is positive. Even way out here, it's really, really short, but it's still going upwards. So everywhere the slope is positive, and it's going to satisfy all the conditions we needed. I really hope that this video was helpful for all of you in preparing for your test. Check out some of my other videos. I have other test reviews that I've done. I've done other videos on these sorts of topics. Check some of these out. Hopefully they will help you be able to prepare for the test. I hope you have a great rest of your day, and good luck with all of your math.